Welcome to Summarize Science. Today, we're looking at a fascinating development in the world of 3D technology. 3D Gaussian splatting is a popular way to create immersive digital environments, but researchers noticed a major problem. Most tools only measure how technically accurate a scene is, rather than how beautiful it looks to a person. To fix this, they introduced AES 3D, the first systematic framework designed to assess the aesthetics of 3D neural rendering. This includes a massive new dataset called Aesthetic 3D and a specialized AI model named AES 3DGSNet. You can see some of their scoring examples here, comparing real-world beauty scores with what the model predicts. Usually, 3D scenes are judged by metrics like reconstruction fidelity, which check for math errors but ignore visual appeal. This research fills that gap by looking at higher-level attributes like composition, harmony, and visual interest. They argue that 3D beauty isn't just about one flat image, but how the whole scene feels from many different angles. To create their dataset, they used a powerful multimodal AI called RTMuse to act as an expert judge. This AI evaluated thousands of views across 8 specific dimensions, including visual elements and technical execution. These ratings were then combined to create a reliable standard for what humans generally find beautiful in 3D. Their analysis shows that 3D aesthetics are highly dependent on the viewpoint of the camera. A scene might look great from one side, but cluttered from another, with some scenes showing a massive gap in quality, depending on the angle. This highlights why judging 3D content is much harder than judging a simple 2D photograph. The team developed AES 3DGSNet to solve this problem efficiently. Unlike other methods, this model doesn't need to render heavy images to see what's going on. Instead, it looks directly at the 3D particles, or Gaussian primitives, which makes it incredibly fast and lightweight. The model uses a clever view selector to pick out the most important angles of a scene. It learns to ignore redundant or blocked views, focusing only on the spots that best showcase the scene's layout. This mimics how a human might walk around a digital room to find the best possible view. When tested, AES 3DGSNet outperformed older models in predicting how humans would rate these scenes. It proved to be more accurate than 2D models because it truly understands how objects are arranged in 3D space. The results establish a new benchmark for how we measure the success of 3D-generated content. In the bigger picture, this work could have a huge impact on how we build virtual reality and video games. It could help creators automatically identify and fix ugly or awkward parts of their digital worlds. By providing instant feedback on aesthetics, it saves developers hours of manual review. The researchers even double-checked their AI's ratings against real human volunteers to ensure they were on the right track. The humans and the AI were largely in agreement, proving the model actually captures human artistic values. This is a major step toward making AI more sensitive to art and design. To wrap things up, AES 3D provides the first systematic way to measure beauty in 3D neural rendering. They've built a solid foundation with a huge dataset and a highly efficient, lightweight model. In the future, this could lead to AI that doesn't just create realistic worlds, but truly beautiful ones. Thanks for watching Summarize Science.